Okay, guys. Dividing part 1. That means there's 2 parts. And what else could we possibly do with radicals? Add them, subtract them, multiply them, divide them. This is it. Okay, this is after tomorrow will be the end of the lesson. So guess when our test is going to be? Probably Tuesday. Okay? Because I'll give you 1 day review, just like grade 10. We'll do review day. I got a little handout for you. Here's what the questions will look like. Hey, it'll be just like your quiz, right? More practice, but like I was explaining earlier, we want to do all of our assignment questions, not just a couple, right? Okay, so is this new? Have you guys ever seen this before?
No.
Yes, you have, because it's exactly the same thing as your Math 10 book, because I just taught that today to the Math 10s. But do I expect you to remember it? No. Let's relearn it. Aha, in previous work. So how do I say this? We can split up a radical. This is square root, because there's nothing there. I can say that's the square root of A over the square root of B. Okay? That was from grade 10. Why do I want to do that? Because maybe I got a question like this. What's the square root of 9/16? I have no idea. But with this rule, I can go that's root 9 over root 16. Do I know what this is? Do I know what this is? Ah, so now I do know what that is. 0.75 if you like a decimals. If you don't, well, just keep it as 3/4. Okay? I can also go back the other way. If it's split, I can combine it, provided the index is the same. If it's cubed root over square root, you can't combine them. You can't split them up. Okay? Well, that doesn't make any sense, but you can't combine them if the indexes are different. The only thing we're going to add in grade 11, and actually you got some of these in grade 10 too, is just make them a little more complex. There's going to be a number in front. I don't know what m is, but it could be anything. Maybe it's a fraction, God forbid. Okay? Just like multiplying. So how did we do this? What were the rules? First of all, can I multiply it? I can multiply it if the index is the same. Is the index the same? Yes. What do I do? Not divide, but just look at the numbers. What's 2 times 4? 8. Okay, what's root 3 times root 2? Root 6. Okay? 10. Okay? So the number first, the radicand second. Now it's not multiplying, it's divide, but it's the same rules. If we can simplify it, we simplify it. Is there a perfect square in root 6? No, there's not. Okay? So just a couple of examples, guys. Divide and simplify if we can. Do you know the square root of 30? I don't. No square root of 6? No. What do I want to do? Okay. Before we give up, can I combine these into one radical? That's the same as the square root of 30 over 6. Do I know how many times 6 goes in 30? Okay. That's definitely more simple than root 30 over root 6. Okay? Square roots to cube roots. As long as it's the same index, are those the same index? Then I can join them. I have 8 over 2 cubed root. All I'm doing is joining them, okay? I didn't do anything else. That's the cube root of 21 over 3. Do I know how many times 2 goes in 8? Yeah, that's 4. How many times does 3 go into 21? So that's cube root of 7. Keep going until you can't get any more perfect cubes in this radicand, and there's no perfect cubes in 7, so that's fully simplified. All right? So could I have started here? Yeah, do that first, but I want to focus on the radical part. Can I simplify 15 over 10? What number goes in 15 that goes in 10? Okay, so let's do that first this time. That goes in there 3 times, 5. 5 goes in 10 twice. Can't do anything else with 3 over 2. Don't make it a decimal, 1.5. Just leave it as 3 over 2. What can I do with root 48 over root 6? Like, if I know the square root of 48, I'm just going to write that number. But I don't. So let's try joining them and see if that helps. Does 6 go in 48? How many times, Dan? I think 6 times 12 is 72. 6 times 8 is 48. It's the simple things in life that are hard. Huh? All right, so that's the square root of... Okay, we okay? Well, I'm not there yet. Let me just get that door. I divided, I simplified, but is it fully simplified? Guys? Can I find more perfect squares in 8? Yes. So 3 over 2, that stays there. Root 8, I want to make what? Root 4 times root 2, okay? So I got 3 over 2. What's the square root of 4? Times 2 times root 2. Do you want to go 6 over 2? Or do you want to go 2 divided by 2 is 1? Doesn't matter, guys. But we should all get 3 root 2. Okay? Some of you guys are going to want to go, that's 3 times 2, 6 over 2. Well, that's also 3, right? Okay? But this is the better way to do it. When we get a couple of lessons down, you'll be doing it that way, believe me. Okay? So are we good with that? Any questions? Okay, we're just simplifying, dividing, just like multiplying, only is dividing, right? What can I do here? Well, can I reduce 4/12? Let's start there. Right? 4 goes into 4 once, 4 goes into 12 3 times. That's the number. Square root of AB? Don't know. Square root of A? I don't know. Let's just join them. So that's the square root of AB over A. Now what can I do? What's A over A? 1. I don't care what A is. So that's 1/3 times the square root of B over 1, which is just B. Okay? Is that okay? I would write another step, but I got no more room there. We see that's the same. Okay, let me ask this. Is that the same as this? Yes, it is. Okay? I don't have to have the 1 there. If you like it, be my guest. But 1/3 times root B is the same as root B over 3, right? The same thing.
So you can write
Either way, yeah. But the book's going to have it like this. So as long as you know this is the same thing, so you don't, okay, get confused, that's fine, right? Okay, just a couple more. They just get a little bigger, a little uglier. First, do the numbers. What's 4 divided by 3? Can I simplify that? No. Do I know the square root of 54? No. Could I simplify this first? Yeah, you could. Did anybody have that question up here? Like, could I have taken a perfect square out of 48? Sure, you can do that first. Doesn't matter. You'd get the same answer. Okay? Let's just join them. Does 8 go into 54 nicely? But can I reduce it? Okay? Forget about that radical. That's just a fraction, 54 over 8. Okay? Can I simplify 54 over 8? Well, I know 2 goes into that. I know 2 goes into that. Let's half them both. So I still have 4/3, the square root of 27 over 4. Does 4 go into 27? Is that fully reduced? No. So am I done? Or can I do something else? We're going to go backwards. I joined them to give me this. What if I split this up again? Do you know the square root of 4? Yeah. So I'm going to go backwards because I know what that is. And also, I think there's a perfect square in 27. Okay? So that's still 4/3. What's the square root of 4? On the bottom I have 2. And what's the perfect square in 27? That's 9 times 3. Okay? This isn't a minus sign. That kind of looks bad. No, that's multiply. But I just want to separate my 4/3 to the radicals visually, right? We all know the square root of 9. Still have my 4/3. Square root of 9 is 3. Root 3 I can't do anything with. I have a 2 down there. Lastly, well, I have like 2 fractions there. I have 4/3 and I have 3 over 2. All I'm going to do is visually rearrange this, okay? That's 4/3 times 3 over 2 times root 3, okay? I didn't do anything there except visually kind of rearrange them. Now, like I said, some of you guys are going to go 4 times 3 is 12. And on the bottom, 3 times 2 is 6, right? Times root 3. And how many times does 6 go into 12? So I got 2 root 3. Okay, any questions? Let me just backtrack. Right here, let's do this the big kid way, all right? What's 3 divided by 3? What's 2 into 4? So you get the same thing, okay? I don't care which way you do it, just make sure you get the right mark. Okay? So a bit of work. Now, like I said, could I just simplify this first? Is there a perfect square in 54? Yeah, I could have done it that way. I'm not going to completely do it like this, but if you want to say to yourself, why is he doing it like that? Why doesn't he do this? That. Root 9 times root 6. And here, let's split that up and go root 4 times root 2. Okay? Does that look a little easier? Okay, I didn't change it. This is 4 times root 54. This is 3 times root 8. Well, what's 4 times 3? 12 root 6. What's 3 times 2? 6 root 2. Okay. That's 2. Let's join these. You get the same thing. It looks like a little less writing, doesn't it? That's another option. Everybody hates that. You want one way to do it, right? Well, there's lots of ways to do math. But if that's the way your brain works, then do it that way. Okay? Let's look at this nice one. 10/20 reduced is what? 1/2. Let's start there. What's a perfect cube in 162? Well, and then think to yourself, some of you guys are doing this. Some of you guys had this at your quiz yesterday. A little piece of paper with perfect cubes. Some of you made it right on your quiz. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. Okay, there's perfect cubes. Which one of those goes in 162? Ah, that one does. Okay. So I want to split up 162 into root 27 times the cubed root of 6. What's a perfect cube that goes in 128? Ah. Cubed root of 64. Come on. Times the cubed root of 2. Okay. Still have a half. What's the cubed root of 27? What times what is 27? 3. Cubed root of 6. Can't do anything with that. What do I have on the bottom? What times what is 64? Cubed root of 2. Do your numbers. What's 3 times 1? 3. 2 times 4? 8. Can I do anything with this? Maybe. Can I join them? Does 2 go into 6? So I'm going to want to join those. Okay. 3/8. 2 goes into 6. 3 times, and I think I'm done.
How did you get the 3
Times this by that. What's a half times 3/4? 3/8. All right? Okay. What do we do with this thing? Let me ask you a question. Does that root 6 go into the root 24?
Yep.
Does it go into the root 48?
Yep.
Or does it go into the root 108? Or is there another option? Do we think it goes into one of them or all 3 of them? Okay, we're good with that? All right. don't write this. You just quickly look here. If we're adding old fractions the old way, I need a common denominator. Do I have the common denominator? Yes. So I go 2 plus 3 over 4, right? So which one of these is over the 4? They both are. Okay? This is over the 4, and that's over the 4. That's helpful, great. If not, well, write it out like this. Every one of these is over the root 6. Okay? Just think about adding fractions. So what do I want to do? Join them. How many times does 6 go into 24? 4 times. How many times does 6 go into 48? Dannon? 8 times. And 6 into 108? Good man. Okay. Now, we're on yesterday's quiz, adding and subtracting radicals. Cassidy. Okay, can I do something with this? Can I do something with a root 4? Hey, isn't that 2? Root 8, who knows what that is? 2 root 2. Some of us got this memorized. How sick. Okay, and this is minus 3 root 2. I have 2 root 2's. Take away 3 root 2's. That's 2 minus root 2, and that's all I can do. Okay, just a couple more. This is going to be a little different. It's called rationalizing the denominator. Okay, all we're doing...
Can we go a little bit slower over these, please?
All we're doing here, and don't ask me why it's simpler, just trust me, it is. How do I get rid of this? What happens if I multiply it by the same thing? What happens to that radical? It cancels out. But I can't just do that. That'll change the question. Whatever I do to the bottom, if I do to the top, then I didn't change the question. Okay? Because what's root 13 over root 13? It's 1. I can multiply it by 1. I didn't change it. So why am I doing this? Because on the top, I'm multiplying fractions, remember? Just multiply straight across. 1 times root 13 is root 13. And on the bottom, I have root 13 squared, which someone says it kind of like cancels out. What do I have in the bottom? What's root 13 squared? It's just 13, right? Or the square root of 169 is 13. That's called rationalizing the denominator. The denominator is not a radical. It's now a whole number. Okay? Like I said, someone says, why is that simplified? This actually looks nicer to me than that. Okay? Well, that's what we do. Okay? We prefer to have the radical on the top than on the bottom. We call this simplified. It's just something you're going to have to, like, trust me. Okay? So that's what this says in English. But again, in math, usually we just want examples. Okay? How would I rationalize this one? How do I rationalize the denominator? What did I do? I multiplied it by exactly the same thing. So what do I have here? Root 2. What am I going to multiply it by? Root 2. Whatever you do to the top, do to the bottom, and then you're fine. Okay, you didn't change the question. What do I have on the top? Root 5 times 2 is root 10. And what's root 2 squared? Just 2. Okay? Well, the square root of 13 is an irrational number. 13 is rational. Okay? Happy with that answer?
No.
Well, that's the answer. So, does it help you to ask it?
We learned rational.
All right. All right. If it's negative, don't multiply it by negative, just multiply it by the radical. Multiply top and bottom by root 6. What do we have on the top? Root 12. What do we have on the bottom? What's root 6 times root 6? 6. Jake. And we have a minus. Okay, that's it. If you multiplied it by minus root 6, you'd get the same thing. Doesn't matter. You just end up with a minus on the top, but that's the same thing. Okay? Now, is this fully simplified? Or is there a perfect square in 12? Yeah, so we actually want to keep going here. That's root 4 times root 3 over negative 6. And that's 2 root 3 over negative 6. Can I simplify 2/6? So negative root 3 over 3. Okay, 2/6 is 1/3, same thing.
On C,
Yeah.
can you times the 6 and 6 together?
The root 6 and the root 6?
Yes.
Yes.
How did you get a 6 out of 2 root 6s?
That's not 2 root 6, that's root 6 times root 6, which is root 36, which is?
Can you show that? Maybe? So that, yeah.
Okay.
I'm getting it. Oh, I don't.
Like when you do steps like that, you don't actually like test these and you don't show it.
Okay, I'll do every step here. What do I want to do to get rid of root 7? I want to multiply top and bottom by root 7. Okay? On the top, what do I have? 7 root 7. On the bottom, I have 3 root 7 times root 7. Okay? Well, let's write it out. 7 times 7, that's root 49. What's root 49? 7. Now, what would you do now? Would you make the bottom 21 and then reduce 7 over 21? Or would you just cancel out your 7s right now? I would too. Okay? But if you want to make that 21, we'll get to the same place. Okay? 7 over 7 is 1. Root 7 over 3. Okay, I think that's enough. 1 to 7, odd, 9, 12, and 13.